Hi guys, let's solve this. So, we have 12 tokens. Choose from any of these. The first player can choose, it's a 1 out of 12, or 3 of 12, they get red. So, first player, so it's a 3 of 12, they get red, times, then it's a 2 of 11, then it's a 1 of 10. Okay, this is just 1/4, and then this crosses out to 5, which is equal to um, 1 over 20 times 11 would be 220 for the first one. That cannot be right. 1 over 220? It's 3 of 12, the first one. Um, the first choice, it's 3 of 12. Then it's, wait, let me not simplify this all right here so I can more easily understand it. 3 of 12 times 2 of 11 times 1 of 10. I guess that's the chances, really. So, 1/4. No, I'll just multiply them all up here. So, 3 times 2 over 3 times 4 times 11 times 2 times 5. 3's cancel out. We're left with 1 over 220. The chance that the second player gets gets all the white tokens would be, so now there's 10, now there's 9 left, so there's 2 over 9 times 1 over 8. And then the remaining just can't be the blue. So we get 6 over 7. Yeah. Which is equal to, this can cancel out with, no, I'm not going to do it there. So 2 times 6, 2 times 2 times 3 over 3 times 3 times 2 times 2 times 2 times 7. So these 2's cancel out, and then this 3 cancels out. So we're left with 1 over 3 times 2 times 7, so 42. For number 3, the final one, is just a 1 in 6. Okay. Okay, so if we just... Do we add these together or multiply these together? If we have, let's just bring it down to 2. we have one black and one white. Player 1, the chance that they get a black is 1/2. Player 2, the chance that they get a white is 1. So if we add these, we get 3/2, which doesn't make sense. If we multiply them, we get 1/2, which does make sense. Let's just try this with a slightly more complex. We have 1 dot, 2 dot, and 3 dot. The chance that the first player gets a 4 dot gets these two is 1/2. The chance that the first player gets one of these three is 3/4, and gets two of these three times 2/4. The chance that the second player gets gets the let's just say it's 1. Yeah, so we can't add these. We have to multiply them. So the thing is, that means I did something wrong, because it's definitely not 1/220 times 1/42 times 1/6. Probably the first, if we have 3 players, one of them gets all 3 of the red tokens. Is 3/12, so 1/4 of this is red. So the first one is 1/4, second one is a 2 11s, then it's 1/10. Then 2 9ths and 1/8, and then 6 7ths that we get one of these. Then it's just 1/6 for the remaining. This all makes sense to me. I think what we might have to do is multiply each of these by 3. Because... okay, let's look at the first one. So the first one could be any 3 of these people. So... if we were to start with number 3, it'd be 1/12. And then 2. It'd be 1/12 and times 6 of 11 times 5 of 10. Number 2 would be sorry. So then we're missing this one and 2 of these. Would be 2 and 9 times 1 and 8 times 4 and 7. And then number 3 in our number 1 would be 3 and 2 times whoa, times 2/5 times 1/4. So this is equal to, this cancels out to 1/2, and then that cancels out to 1/2. So it'd just be 1/44. This that cancels out to 2, and then that cancels out to 1. So it'd be 1/56. And then this, that's just 1/2, and that's just 1/2. So that'd be 1/20. I say it's 56, no, it's 63. So if it's 63, can we just rearrange it to become this? We take a 3 out of this, we get 21, take a 7, 3 and 7 go, yeah, I'm fairly sure these are the same, so I'm just gonna multiply it by 3. So, I'm gonna go down and say this is times 3, this is times 2. So then when we multiply these all together, we have 3 over 220 times 42 times 6 over, and then so 3 times 2, so this cancels out, we get a really big number, which is still not what we want. I don't understand what I'm doing wrong, but I'm gonna see what happens if we add these. 1 over 220 plus 1 over 42 plus 1 over 6. So this would be 7 over 42. So 1 over 220 plus 8 over 42. Divide both by 2. We get 1 over 220 plus 4 over 21. 220 is 5 times 4 times 11. 21 is 3 times 5, or 3 times 7. So, yeah, we just need to multiply both of these by, I need to multiply this by 1 over 220 times 21. So we have 21 over, times 3 would be, or times 7 would be, uh, 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 220 times 21 is 220 plus that times 20. So 220 plus 4400, which would be 2620. 2620 plus 4 over, no, plus 880 over 2620, which would give us 901, which is not divisible by 3. It's not divisible by 5. It's not divisible by 4. Is it divisible by 11? We know 990 is. We know 880 is, so no, it isn't. Is it divisible by 7? 700, and then it's 201. No. Yeah, so this is just, I'm giving up because I have no idea. I'm just gonna say it's D. Gosh, I'm really not winning on these MC questions. Because on this one I feel pretty confident in my way of doing it, but none of the questions are correct. Where did it? Here. Okay. So the answer was 4 over 385. With 12 factorial total possible arrangement of 12 distinct tokens. If we imagine the first 4 tokens of our arrangement goes to the first player, the next 4 to the second, the next final 4 to the third, then we can view this problem as counting the number of valid arrangements. Oh my gosh. Oh my gosh. I did 3 tokens to each player. Not 4. Not 4. Not 4. What was the correct answer anyways? 389. Oh my god. 4 tokens to each player. I need to remember that. I might retry this problem tomorrow, knowing that it's 4 tokens per player, and trying this again. I don't know, because I feel like that's a really basic mistake that I just forgot, and I just didn't remember. But thank you guys for watching. I'll see you guys tomorrow. Bye.